Our universe is a home to a lot of mysterious things. We have spent so many years figuring and sorting them out. There is something which attracts everything that comes across it like a magnet, but it has no restrictions for the objects. It seems very small but indeed very dense and looks nothing more than a highlighted loop. It represents strong attractive forces which are unable to be calculated incomplete even with our advanced technology. A so-called hollow place filled with darkness. Black hole. Before we could go any further, in order to show your support to our content, do not forget to give a thumbs up and share the video with your friends and family members. In the meantime, subscribe to our channel and ring the notification bell so that you will be the first one to watch our videos. In 1916, Albert Einstein was the first to predict the existence of black holes with regards to his general theory of relativity. Then, John Michell mentioned it as dark star, which means gravitationally collapsed object. So, the term black hole was traced from physicist Robert H. Dick, who compared this phenomenon to the black hole of Calcutta, a prison where people entered but never left alive. However, the term and name became official when a student suggested it to John Wheeler, an American astronomer at that particular period of time. We were able to imagine and simulate black holes so that we can deepen our understanding about it. But it was not until 2019 the Event Horizon Telescope (EHT) released the first image ever recorded of a black hole. Now, we will get to know the vital details about a black hole. How is it formed? There are 4 types of black holes, but today we will only see 3 types: stellar black holes, supermassive black holes, and intermediate black holes. Usually, when a star collapses, as soon as the fuel of the stars is used up, its core becomes a neutron star or a white dwarf. Well, that's the case of small stars, but when a very large star completes its cycle and reaches the last stage, the core is compressed, causing a very highly dense mass which is called a stellar black hole. This type of black holes pack more than 3 times the mass of the Sun into a diameter as small as a city. Soon they start to consume matter around them, leading to the expand in size. The second type, supermassive black holes, is solely based on the basic process of formation as well. However, the difference is found in their size, mass, and concentration of gravitational forces. It's a result of few small black holes combined into one to form this supermassive structure. That explains why they are located at the center of each galaxy, as well as their size, billions of times greater relative to the Sun. Sometimes it is said to have formed from large clusters of dark matter. Dark matter is a substance we can observe through its gravitational effects on other objects, but we don't know their composition because dark matter does not emit light. Apart from that, recent research has revealed that intermediate black holes are in the middle of the other 2 types in terms of size. Well, it is slightly hard to differentiate them and very close observations are needed. A research in 2018 suggested that these mid-sized black holes may exist in the heart of dwarf galaxies. Structure and characteristics. When it comes to the structure of a black hole, there are 3 parts to be considered. Singularity is the center of a black hole. It's the point where all the gravity and mass of black hole is concentrated. Technically, singularity is nothing more than a dot in visual means. On the other hand, event horizon is what we call the space surrounding the singularity. Then, Schwarzschild radius is literally the distance of black hole's region from the center. from the aspect of characteristics. Mass, charge, and angular momentum are the only units featuring black hole. Scientists evaluate in terms of these properties to study, differentiate, and categorize black holes in our universe because they are seen to be black and empty space in the middle of a bright ring caused by light. There is a reason to this, in fact. The gravitational force produced by a black hole is far too great that even electromagnetic radiations cannot escape the event horizon. Visible light is also part of the electromagnetic spectrum. We see objects as the light is reflected from the objects to our eyes. So when light cannot escape black hole, we are unable to witness or capture the internal features of it, which makes it to look hollow and dark. Indeed, that is how strong the gravity inside a black hole is. Whatever the objects that enter the event horizon of black hole, they will never escape the region. Once the object reaches the singularity, the mass of the object is added to the black hole's mass. Well, it explains how a black hole expands in the first place. Theoretically, as referred to spaghettification or noodle effect, tidal forces rip apart the objects into atoms just before they are crushed to infinite density due to the massive gravitational forces in the black hole. Predictions. Many sources predict that black hole is a dead end where there's nothing else after entering them. It's said that one day even the sun can end up as a black hole, sucking our solar system and bringing it to a forever end. That can be how our universe will meet its last stage after all. Instead of that, black hole is believed to be bending our space-time continuum, consisting 3 dimensions of space and time as the 4th. So black hole is assumed to cause time dilation, slowing time and supposedly allowing successful time travel. Imaginarily, an observer far away from a black hole can notice a clock ticking slower than usual as it nears the singularity. But for the person holding the clock, it would be normal because he is already part of a time dilation. In the meantime, theories speak of another term, wormhole. Assumed as a portal having a black hole at each of its ends, this so-called portal can be a way to another universe. At least, that's what people imagine it to be. Close to that idea, a Russian cosmologist also suggested that a black hole leads to a white hole. Unlike a black hole, white hole does not allow objects to enter the region and only emits them outside. Typically, it is believed the matter entering black hole finds exit through a white hole. All of these are basically just theories. Many scientists believe that facts about black holes can never be actually proven. But hey, who knows what the future holds? So keep learning and thinking. Let's like, share, comment, and subscribe to support our content. Signing off, Quantum Vimana.